This is question number 43 of GATE 2017 Metallurgical Engineering. For homogeneous nucleation of solid in a liquid of a pure metal, the critical edge length in nanometer of a cube shaped nucleus is given surface energy equal to 0.177 joule per meter square. Change in volume free energy delta GV is equal to minus 2.8 into 10 to the power 8 joule per meter cube. So to know more about the nucleation, you can refer lecture on nucleation by Professor Rajesh Prasad from IIT Delhi with the course Introduction to Materials Science and Engineering. Now to solve this problem, so let's say we have a liquid metal which is going to cool and form a solid nuclei inside it. So let's say this is our cubical shape nucleus which is forming inside a liquid pool, right? So there are basically two things happening. The first thing is the creation of solid surface, which is a new surface inside a melt pool, which will be giving rise to the surface energy. And the other thing is due to liquid to solid transformation, there will be a release of volume free energy, which is given here in this problem. So if you try to calculate the free energy change due to formation of solid. So if you try to calculate the change in free energy due to formation of this cubical shaped solid, it will be equal to let's say this free energy is denoted by delta GF, and this will be equal to the surface energy, which is gamma, times the surface area of nucleus or nuclei, plus the change in volume free energy times volume of nuclei, right? So this is the relation which will give you the energy balance, right? Now in our case, what will be the surface area of the nuclei? Since it is a cubical shape, so the total surface area which will be creating it will be equal to 6 times the edge length square. So let's say A is the edge length, so 6 times the edge length square will give you the total surface area. So plus delta GV times volume of nuclei. So since the edge length is A, the volume will be given by A cube. So A cube will be the volume of this nuclei, right? Now to calculate the critical edge length, right, what we can do is we have to differentiate this free energy change with respect to the edge length. So we have to calculate d of delta GF upon dA, and this will be equal to 12A times gamma plus 3A square delta GV. So in order to have a critical edge length or this minimum edge length, what we can do is we have to equate this differentiation with 0. So if this is equal to 0, this will give you the minimum edge length of which we can form a stable nuclei, right? So if you equate this with the 0, what will be the value of A which we will be getting is, so A will be equal to 12 gamma upon minus 12 gamma upon 3 delta GV, right? So this is nothing but minus 4 gamma upon delta GV. So the critical value of A, let's say it is A star. So A star is basically given by minus 4 gamma upon delta GV. So this is the minimum value of A with which we can form a nuclei, right? Now to calculate the value of this A star, we will simply put the value of gamma and delta G in delta GV. So the value of gamma is given in the problem is 0.177 joule per meter square, and the value of GV is 2.8 in minus into 10 to the power 8 joule per meter cube. So if you solve this, you will get 2.52 nanometer, the value of critical edge length. So this will be the right answer for this problem. So 2.52 nanometer will be the critical edge length. Thank you.